Hey, what's up, guys? This is Chung here. So today, let's take a look at this problem number 1320. Minimum distance to type a word using two fingers. Okay, so you're given like a keyboard layout as shown about like this, right? There are like 26 buttons on top of it, right? Uh, they're sorted like I mean alphabetically, right? And then like the letter A is in the zero. It's located at 0, 0, so on and so forth. The last one is a Z here. Okay, and then you're given like a word, right? A word is your input, and they ask you to return the minimum total distance to type each string using only two fingers. Okay, so the distance between the coordinates, the distance between two coordinates is calculated as this, basically the absolute x difference plus the absolute of the y difference. Okay, and then the initial position of your two fingers are considered free. So what does it mean? It means that, okay, so it means that so the first letters, right, is always free because you before typing the first letters, there's no distance like calculated. So which means you for the first word it's free. Okay. Yeah, and then also your two fingers do not have to start at the first letters on or the first two letters. Okay, so this is just like a further clarification, right? Basically, you can use your fingers to type in a few letters, and then you can use the other one to type the others. Okay, cool. So, and then it gives you a few examples here, right? But let's go back to this diagram here, right? So to this keyboard here. So I mean, so this problem, I think it shouldn't be that hard to come up with like a dynamic programming problem, right? Because it's clearly that at each state we have we have a few options, right? We can either move our left finger, or we can move to our right finger, or we can move our right finger. So at each state we have those two options, right? So that's why I mean it's a perfect candidate for us to use dynamic programming to calculate this problem. Again, okay, so now with dynamic programming, so the most important thing is that we have to define the the definition of our state. Okay, so I think for this problem, I think it's pretty straightforward, right? Basically, we have like dp here, right? And then we have dp what? So the first state is like the first data, I'm going to have a k here. So the k means that we are at the kth letter here, okay, because we are typing the word from left to right. So I mean, it's obviously the first dimension of a DP is the current letters, right? Basically, how many letters we have typed so far, okay? And then the second one is obviously our left finger, it's I, and then we have a J is our right finger. So, so I believe this DP definition shouldn't be that hard to come up with, right? Even though it's a like three-dimensional DP, but since it's clearly telling you that you have two fingers, so which means that at each state, any of the two fingers can add any of this boards here, which means the I and J, the range is in the 26, right? And the K, of course, is the length of this word here. So once we define this like DP definition, right? And then the next thing is always how can we maybe come up with the state transition function, right? Basically, with the current state means we have processed case letters, and then our current left finger is at I's location, and our right finger is at J's location. Okay. So what does that mean, right? So basically, since we have processed the current case letters, right? So we know that what's the case letter, right? So we know the word K here. We know the word K, right? So with the word K here, we know so either I or J is at this word, at this letter, right? Because that's the definition of our state, right? So either the left finger is currently at this letter case letter here, or the right finger is at this finger, or the right finger is at this case letter. So with that, we can easily we can easily calculate all the scenarios that can get to the current state by from the dp k minus one state. Okay. Okay. So what's going to be the previously state of this, right? So let's say the current letter is k here. Sorry, the case letter is q here, right? So how many different scenarios move we can come to this state here, right? Basically, the total combination is the left finger can add any position out of this 26, right? That's gonna be the first 26 possibilities, and of also the right finger can also be at any of the 26 possibilities. So in total, at each state, we have 26 times 26 different ways on at k minus one state that can get to the current state, right? Basically, we just need to consider all of those scenarios, and we'll get the minimum value out of them, so that we can get the minimum value, the minimum distance for this current DP state here. Okay, and because we have two fingers, right? Again, that's why to get to the current state, I and J here, right? We can use the DP, so I uh II, right? And JJ plus the distance the distance from II to I, or from the JJ to J. That's the distance. Okay, depending on if we are considering J is pressing at the current word, or the I is currently pressing at the current word, right? Basically, if the I is currently pressing at the current word, then the distance here will become the distance of II, and I, right? Otherwise, if you're considering uh, J is pressing at the current word here, then the distance will be what? Will be the distance of the JJ and J. Okay. Yeah, so that's basically the state transition function here, right? And then we'll get the minimum out of these things here. Okay, so I'll explain a little bit more while I'm doing the coding here. So I think first thing first, right? Let's do an nlog word here, right? So that's the first dimension, and to define like a three-dimensional arrays in Python's, uh, and also since we're going to get the minimum values, so at the beginning I'll be starting at the maximum value for each of the elements here. So we have a 26, right? And then for in range 26. Okay, so that's the first that's the last two state, right? And then out of this we also have a third dimension, which is the in this case it's going to be the range of n. Okay, so that's how we define like the three-dimensional DP, right, in Python. So n at the beginning, everything is maximum. So since it's maximum, we have to get the we have to set the base case. Otherwise, we'll, in the end, we'll always get the maximum value, right? So then what's gonna be the base? You know what? Actually, let me try to finish the main logic first. So we have a in range one to n. Okay. So this is because we are at the step number uh we are at the second word here. Mm. Yeah, so we are at the second letter here. So now we need to get the current letter, right? Because so the next step is with the current letters. Since remember we're defining like the index of each letter here, right? And we have to get the current index so that we can map this word into one of the index in this DP array here. So we have index, right? So the index is going to be what? It's going to be the word of word word k, right? Minus of ordinate or ordinal of the word the letter a. Okay, so that's how we get the current index. The index is zero from 0 to 20 to 25. Okay, so now we have the current position. Basically, so this index is either it's going to be the DP DP K I and J, right? So basically, this index will be either like at this the left finger or at the right finger. Okay. So now we just need to have loop through everything, right? Loop through all the possible scenarios that can get to the current state, right? So the first thing is the uh, first thing is let's assume like move left finger, right? Move left finger to the index, right? So that's that. So basically the dpk. So if we're moving the left finger to the current index, so which means the current state is the current left index, left finger is at this index, right? Uh, and this thing is at J here, right? So that's that. So we're gonna have a minimum of dp of k, the index, right? And then the J dot what? Dot dp of k minus one of the of I, right? So I and J plus a distance, right? We need to get the distance. Basically, so the J that doesn't change, right? Because the right finger stays the same. But the left finger got changed. Basically, changed from the current from I to the index, and we need to get the distance for this index and I here. But how? So and then let's define like helper functions, right? Get distance, right? So it takes like two index. You got index one and index two. So as you guys can see here, we are defining the index from 0 to 25, and to be able to calculate the distance, we have to convert them into like x1, xy coordinates, right? So xy and x2, right, equals to what? The div mod, basically, I1 dot 6, right? I think you guys know this one, right? Basically, the x is The x is the division after division by 6, and oh, sorry, and the y1 is the modular uh, divided is a modular of 6. That's how we get 0, 1, 0, 2, 0, 3, 1, 0, 1, 1, so on and so forth. Right, same thing for the x2 and y2. We also could do a div mod of I2 dot 6, right? So now we can return the absolute value of the x difference, right? X2 plus the absolute difference of y1 and y2. That's how we calculate the distance. So now here we have since remember, so we move the left finger to the current to this index, to the current index. That's why we're gonna pass in the I and index, right? So that's that. And of course, so we can but mostly copy and paste these things. So now we need the next one is to move the right finger to the current index. To move the right index finger, so we have the the J at index, the J stops at the current index, right? So I'm gonna copy these things here. Then it's gonna be I here. So again here, right? So it's still also like I and J, but at this time we're gonna have like a J, right? Because we're moving J in this case. So that the distance for this case for this for loop is from J to the index. Okay. So and in the end, right? In the end, we just need to get all the values, right? At the last step. Basically, I in range 26, and then for J in range 26. Answer equals to minimum answer dot dp, the last index of I and J, right? So this things means that at the last step, our left and right finger can end up at any location, at any of the position on this keyboard here, so that we just need to consider all the possible scenarios out of at the last step to get our final answer, right? And then in the end, we simply return the answer. Basically, that's the main logic, right? For this problem. Now let's go back to here, right? So we're starting from 1, right? Because since we have this k minus 1, but we haven't initialized the 0 case, which means as the first step, right? So it already told us, right? At the first letters, right? It basically is it's free. So keep typing the first letter is free for us. So which means that for I in range 26, okay. Uh, Basically, we have dp0, right? We have dp0, and then so the first letter is what is the first index equals to word 0. So basically, I just copy these things here, right? Word 0. So it means that at 0, right? Basically, we can have either left finger or the right finger press the first letter. Well, right? It means that, okay, so for example, if we use the left finger to press the first letter, right, it means that how about the right finger? So this thing should be equal to 0, right? But we have 3 dimensions, right? That's why we have like this I here, right? It means that if we use the left finger to press the first letter, so the right finger can be at any locations. Okay, right? Because it doesn't really matter actually. That's why we initialize everything for this case to be 0. And same thing for the right, same thing to press the first letter with the right finger, right? So we just in this case the left the left finger can be at any locations, right? So that's how we initialize this the first step. So this will guarantee that uh, our following state transition can get the correct answer. Cool. I think that's it. Let me try to run the code. Hmm? Int is not iterable. Minimum dpk plus. Oh, sorry. I think get distance. Maybe this one here. Okay. Yeah. So the test case accepted. Let me try to submit this one. Yeah. So it passed. I don't. Hmm. It's pretty slow. Hmm. Anyway, maybe there's a better solution, better approach for this one, because as you guys can see here, so the word length is 300, right? And it's pretty straightforward. It's a straightforward that we have. What's the time complexity for this? We have like this is like minor. So we have an n here, right? So we have an n times this, right? 26 times 26. Yeah, so that's the time complexity, right? And the space complexity is also the same. Space complexity is the same thing here. Time is this, space is also this. Yeah, pretty straightforward, right? So yeah, I think just to recap this problem, right? So this one is I think it's one of those classic DP problem, and with three states. You know, every time when you guys see like this kind of like typing things, if you're doing if you're doing it with one finger, then it won't be a like a DP problem, right? Because with one finger you only have one scenario to type in the whole word. So the reason this one becomes a DP problem is that at each state you have two options. You can either use the left finger or the right finger to do this, right? I mean, actually, this problem, if you're using like a top down, I think it'll be more straightforward. Yeah, I think top down is better than the uh, than bottom up. I think because because for the bottom up, as you guys can see here, we are like actually we're looping through all the possible scenarios, right? All the possible scenarios uh, from the previously state. But I think if you're using a top down, mm, we won't necessarily be looping through all those 26 by 26 at each of the scenario because if we start at this word here, right? I mean, yeah, actually, you know what? Let's try to do a top down real quick here. Okay, just give me 1 second. So let me quickly implement the top down. I think top down is better for this. It's better for this problem, you know. Okay, so to implement the top down, right? So I'm gonna comment out these things here, right? So we're gonna need everything else, okay, except for this, right? So we're gonna have like a DP here, right? So we're gonna have same K, I, and J, right? So, and then we're gonna have a memorizations, right? Goes to this, and then in the end, we simply return the DP. Basically, we start from the first letters and so this part, right? So how about our fingers, right? At the first letters, the finger doesn't really matter. It can either start from from any of the location. It's just that at the first letters, the movement is free. So how can we check that, right? So I think one way is to we can just pass in like some special values here, right? Like for example minus 1, which means the it's a it's and it says the telling us the okay, so it's a first movement. So whenever it's a first movement, it should be free. So which means that we can just simply modify this get distance. Do we have distance? We have a uh, okay. We just have a uh, the distance here, right? I mean, basically, if the a equal to the -1, or the b is equal to the -1, and then we return 0. So that's the only thing we need to change here. Okay. So that I mean here, I think we have a template, right? So if the k, I, and j are in the memorizations, right? And we return the memorizations. Okay. Okay. So then here the answer, return the answer. Okay. Okay, so here we have answer here, and then define the answer at the beginning of the system max, right? So that's the template basically, and the now it's the main logic, right? So we have a current index, right? The current index is like the word of the similar as the bottom up, right? K minus ordinate of A, right? And now we only have two options since we're moving forward, right? So this is basically following the same the description of this problem. Basically, we are typing the words. So by typing the current words, we only have two options, right? Basically, we have dp. Uh, so the next state. So what's going to be the next state? So next state we are moving the case by 1. This for sure. And second one is that assuming we're typing the current word, right, with the left finger, that it means that the left finger will be on the index, okay, and the right finger is still J, right? So and then we just add the get distance of the current this index plot comparing with the previously left finger index, right? So that's how we get the distance. And then the second one is basically typing the current word with the right finger. So which means the right finger will be current index and the left finger is still the I. So same thing here, right? So now we have a current index with J. Okay, so that's that. I mean, and the last thing is that we just need to return the base case, which is the k equals to n, right? So in this case, whenever we have tapped everything, we simply return 0. Basically, there's no more movements needed. Okay. Yeah, I think that's it, right? I mean, run the code. So this one accepted, submit. As you guys can see, so this one is much faster than the bottom up one. So the reason being is that it's like this, right? As you guys can see here, so for the top down, sorry, for the bottom up scenario solutions here, for each of the state, we need to basically uh, brute force all the possible previously existed states, because with the current state, basically the numbers can be moved from any of those 26 times 26 combinations, right? So that's why we have to loop through everything here. And instead, for the top down scenario solution here, we only have like two options here. So basically, with the current state, we only have two options. We either go with our left fingers or go with our right fingers. I mean, even though the time complexity is the same, but with the top down, we will process much less state. Cool. Yeah, I think that's it for this problem. At least for this problem, top down is better than the bottom up. Uh, Hopefully you guys can tell the difference between the top down and the bottom up, and why the top down is better than the bottom up for this problem. Okay, thank you so much for watching the video, guys. Stay tuned. See you guys soon. Bye bye.